This video is on quadratic functions, factor/intercept form. We're going to do some examples on here. This first problem, we are given an equation and we need to fill out the chart with all the information, and then we're going to graph it on this coordinate plane. So right now it's in factored form because we have it in parentheses, and this negative 3x we could distribute back through to get to standard form. So the first thing we need to do is find our x-intercepts by using the x values. So we have a negative 3 as our a value, but this next part is an x. Anywhere you see an x, that's what you have to look at. So what is the value that would make this x here 0? This one's rather easy because it's in the parentheses. So if I say x minus 2, I want it to give me the y value of 0. So if I said 2 minus 2 would give me 0. That's my first x, that's one x-intercept, is at 2, 0. And you can also think of it as you're changing the sign of that negative 2, it's 2 comma 0. Because it's 2 minus 2 gives us the 0. So what value of x right here would give us a 0? Because you have an x by itself, it's not added or subtracted anything, 0 would make this x 0. So that x-intercept is actually at 0, comma 0. It's at the origin. So now we want to find the vertex, but in order to find the vertex, we have to find the axis of symmetry. To find the axis of symmetry, it's going to be you're adding the two x-intercepts. So 0 plus 2 over 2 is equal to 1. So that means that our axis of symmetry is actually at x equals 1. We have to make sure we put it as x equals. So now we can find the vertex since we have the x value of the vertex. We plug this x value into the original equation. So I'm going to write my work down here. So to find the vertex, we plug in the 1 into this equation. So it's y equals negative 3 times 1 times 1 minus 2. So y will equal to, so we have negative 3 times 1, and then 1 minus 2. So 1 minus 2 is negative 1. Negative 1 times 1 is negative 1, times negative 3 is a positive 3. So the y value of our vertex is 3. Our x is 1, our y is 3. So we have a vertex at 1, 3. Now we're going to find our y-intercept, which is very similar to our vertex. We just plug in 0 for our y-intercept. So for our y-intercept, I'm going to write down here again. We have y equals negative 3 times 0 minus 2, which negative 3 times 0 is automatically 0, so y equals to 0. And if you think about this x value was already 0. That means that automatically should have given us our y-intercept of 0, 0. Which way does this open? You look at the a value. A is equal to a negative 3. That means it's going to open down. If it opens down, it has a maximum value. That value is, again, the y value of a vertex. So that value is actually at 3. The domain is always open bracket, negative infinity, comma, positive infinity, open bracket. And our range comes from if we have a positive or negative. So our range, we have a negative a, so that means we're going to have a negative infinity because it's opening down. So negative infinity is always on the left, and then it's going to go to that positive 3 because that is the value. So we have an open bracket and then a closed bracket. So we have our chart. Now we want to go and graph our coordinates, any coordinates that we have. On this coordinate plane, we do have what we're counting by, but we do not know which side is x and which side is y. So you should always put x on the right-hand side and the y on the top. Okay, let's graph our x-intercepts are at 0, 0 and 2, 0. Let's graph our vertex at 1, 3. Our y-intercept is already graphed as well. We need to graph our axis of symmetry. It's that vertical line through that vertex. I'm going to label it as AOS x equals 1. You must label it as AOS x equals 1. Now, we have no other coordinates, and we want to have 5 so we can make our graph accurate. So that means we need to find another one. We already have our y-intercept, and we have the mirror of it. We have our vertex, we have our x-intercept. So we need another coordinate, and we can do the mirror of it. So we just need to find one more coordinate. So if you can make just a little table of what we have. I'm going to show you how to do that. If we look at what we already have, x, y, little sideways table, we want 5 coordinates. We have our vertex is at 1, 3, so I'm going to put that in the middle, 1, 3. Right beside it, so beside 1 would go 2. So I'd put 2, we already have that at 0. And then to the left of 1 is 0, and we have that at 0. So what we want to do is find another coordinate either to the right or to the left of our vertex, so we can actually just multiply something. So let's just go up to 3 maybe. So let's do 3. If we do 3, what we're going to do is do the same thing we did when we had x equals 0 and x equals 2 and x equals 1. We are literally just going to plug in x equals 3 into the original equation. So y equals negative 3 times 3 times 3 minus 2. So we have 3 minus 2 is 1. 3 times 1 is 3. 3 times negative 3 is negative 9. So our y value for this one would be negative 9. If we move the same amount, so if we went up 1 from the 2, if we go down 1 from the 0 at negative 1, that means that this y value will mirror it. So this will just be a negative 9. We don't even have to plug in that negative 1. Because it's the same distance away from our axis symmetry, so we went up 1 more. Down 1 more. So then the y values have to mirror each other. So we can graph these extra coordinates to get a 5th coordinate. So it's at 3, negative 9, and negative 1, negative 9. And you can see that that is a mirror from it. 1, 2, 1, 2. Now we can actually draw in our parabola. And this does open down like we said. It does go up to positive 3. It has our x-intercepts, our y-intercept, and we have these coordinates. On these next examples, we're actually going to use information to create the equation. Instead of being given the equation, we're going to use everything we know to be able to create it. So we're going to write the equation of a graph in intercept form, and we're going to be given the 2 x-intercepts are at 7, 0, and 1, 0, and we will have a minimum point. So we do know it's going to open up, so that does help us a little bit. So if we think about it, factored intercept form, we want to write the equation. That means when we write an equation, x and y in our answer are letters. So our letters in the answer. Okay? They are letters in the answer. So let's think about what we have for intercept form. Because it is intercept form, we do have the original equation for that. That was the y equals a parentheses x minus m parentheses parentheses x minus n. So that we can plug letters in until we get everything we need. This is the original one we have. So we have a y, a, x, and m, and n. So there are 5 letters. So I'm gonna write out those letters: m, n, x, y, and a. Now, in order to write the equation, we have to have all of the letters to have value so we can write it in, but then our final answer will have x and y as letters. So let's use the information we have and fill this in as much as we can. So the x-intercepts. Are your m and n. So this 7 is your m value. The 1 is your n value. We still have another coordinate. So a coordinate is an x and a y. So actually on here, we can use our x and y are 4 and negative 10. But we have no other information, and we don't know what a is. And that's what we're actually supposed to find. So this is our question. This is what we're trying to find. So we're going to use, we'll use this information to be able to find a. So let's plug it in. Our y value is negative 10 equals, we don't know our a value yet, parentheses, our x value is 4, minus our m value is 7, parentheses, parentheses, our x value is 4 again, minus our n value is 1. Okay, so the left-hand side, nothing can change to that yet. It's equals a, parentheses. 4 minus 7 is negative 3, parentheses, parentheses. 4 minus 1 is positive 3. Okay. So the left-hand side is still fine, so negative 10 equals a times negative 3 times 3 is negative 9. So we really have negative 10 equals negative 9a, because that's a multiplication. Now we're going to get a by itself, so we're going to divide by that negative 9. So a will equal to a positive 10 over 9. And since it was minimum, we knew a had to be positive, and we were right. So this is positive 10 over 9. Now that we have all of our letters that have values with it, now we can actually go back in and write our actual equation. But in our actual equation, x and y are letters. That means that we have to use the numbers for m and n. And we also have to use the number from a. We're going to use letters for x and y. So come back here. So y equals. We're going to put y equals because we're using the letter. A is that 10 over 9. Parentheses. X, we're going to use the letter x. Minus m, so minus 7 is just going to be minus 7. Parentheses, parentheses. X, still just x. Minus n, so minus 1 is just minus 1. And this is our equation. So again, we had to use the information we had to be able to figure out what a was. Once we found a, we just used the numbers for m, n, and a to write out an equation. If we look at this next one, it says write the equation. So again, same information of a graph in intercept form. So again, intercept form, but you're given only one x-intercept. Is at 2, 0. And you're given a point of 0, 6. Now the thing is that you're given one x-intercept. You only have that one x-intercept. It doesn't mean that I'm not giving you all the information you need. It means that there is only one x-intercept. And if you remember from before, only one x-intercept means that it actually bounced on that x-axis. So at 2, 0, and it's going to go to 0, 6, it's going to bounce off of it. It's going to bounce there. So that's actually also going to be your vertex. What that means is instead of using x minus m and x minus n, which you can, it's just that that x-intercept is happening twice. This equation is actually y equals a parentheses x minus m parentheses squared, because it's happening twice. This time we have an m value, we don't have an n, x, y, and a. So our m value on this one is going to be 2, because that's our x-intercept. And then we have a point, a coordinate. This is just a random coordinate. This is the y-intercept, but that's fine. It's a random coordinate. It's 0 and 6. So x is 0 and y is 6. A is our question mark. We're going to plug them in. The y value is 6 equals a value is our question. We're going to put a, parentheses, x is 0. Minus m, so it's minus 2, it's just minus 2, parentheses squared. We have 6 equals a, parentheses, 0 minus 2 is negative 2, squared. we have 6 equals a times negative 2 squared is a positive 4. So we really have 6 equals 4a. We need to solve for a. We will divide by 4. Therefore, a equals, it's 6 over 4, which is actually 3 over 2. So if you simplify it down, you'll get 3 over 2. Now that we have a is 3 over 2, we can write our actual equation. And again, we're only going to use the m value this time and the a value. Again, x and y are just going to be letters in our final answer for our red. So y equals a is 3 over 2, parentheses, x is just a letter, minus m, that was minus 2 again, parentheses squared. And this is our final answer. When it has only one x-intercept, that's when you use the squared. However, you still could have used m and n. Both of them would have been 2. You would have had m equals 2, n equals 2 as well. This last problem says use the graph provided to write the equation in intercept form, then write in function notation. So we're going to use the graph provided to write the equation. We're still going to write the equation in intercept form. That means that we need to get the x-intercepts. Okay? In intercept form, you have to have the x-intercepts. You have to have your m, your n, anything you can use. Okay? So y equals a parentheses x minus m, and because there are 2 of them, we would have the x minus n as well. M equals, one of our x-intercepts is at negative 5, 0, so negative 5. N, the other x-intercept is at negative 3. And then we need another coordinate, any coordinate, because we need to have an x and a y, so we can find our a. We do know that our a is going to be negative, so that's a good check to see if we're doing it right, because it's opening down. We just need a random coordinate. It can be the vertex, it can be a y-intercept, it can be any coordinate except for the x-intercepts. So it's perfectly fine to be able to use that vertex as long as it's a good, clean coordinate. It is at negative 4, 1. You could also have used this coordinate, because it's a clean coordinate, it's at negative 2, negative 3. So either one is fine. I am going to use the vertex negative 4, 1. So negative 4, 1, and I'm going to put a question mark on a. I'm going to do the same thing. Y equals 1. Don't know a. Parentheses. Our x is negative 4. Minus a negative 5 really means plus 5. Parentheses, parentheses. X is negative 4. Minus a negative 3 is really plus 3. We have 1 equals a parentheses. Negative 4 plus 5 is 1. Then negative 4 plus 3 is negative 1. 1 equals a times negative 1. We really have 1 equals negative 1a. We will divide by that negative 1 to get a by itself. A equals to negative 1. So now that we have our a value, we can write our equation just like we just did. We're going to use our m and n. We're going to use our a value. Come back to the original equation. So y equals, this is going to be a letter. A is negative 1, parentheses. X is going to be a letter. Minus negative 5 was really that plus 5. Parentheses, parentheses. X is a letter again. Minus negative 3 is really plus 3. So this is the equation, but we also want it said to write in function notation. Now function notation, again, we needed to use that key point. If f of x equals x squared, we know it's supposed to be a. Our a value we just found was negative 1. F of x. Now, what was the key point? The key point is actually supposed to be your vertex, which, if you remember, I used that one to help us find the a. So we do have our vertex. It's at negative 4 comma 1. So f of x is going to be minus the x value of your vertex. So minus a negative 4 is really plus 4. And then we're going to keep the value of our k. So we're going to keep this y value as plus 1. So this is function notation. This is our equation in intercept form. And this is function notation, which actually gives you your vertex as well.